This is a 90% efficiency furnace, and this furnace is designed to extract up to about 90%, a little bit more, of the heat that you're consuming and put it into the house, compared to some older furnaces that actually use a lower percentage. Now, the components of this furnace is, here is the burner section, and behind it is the combustion section, where the flames actually shoot a flame inside of the combustion chamber. This is the combination gas valve, and this gas valve is designed to stop the flow and to start the flow of gas into the burners here. So this bar here is actually a pipe, and this pipe is the manifold. And the manifold has orifices, one for each of the burners. So as this is energized by 24 volts, it will allow gas to flow through the pipe into the manifold and through the orifices into the burners, and the flame will go inside of the combustion chamber. The other component of it, because of the high efficiency of the furnace, it has an induced draft motor. This induced draft motor is designed to force air into the heat exchanger to remove the flue gases. And what it does is, as it's pulling the flame in, it actually takes primary air, pulls it inside of the combustion chamber, and allow a draft to go through the heat exchanger, get collected inside of the blower, and exhausted out to outdoors through this PVC pipe. This is the motor, and inside of this blower housing is a blower wheel, which will cause the movement of flue gases. Also part of this is safety. There are safeties, which is our pressure switches, to allow the system to sense that there's airflow through the flue gases through the combustion chamber. The problem is, if there was no type of safety, it can cause a problem with if the blower didn't operate, and cause the flame to overheat the furnace and cause destruction. So this is actually sensing movement of airflow through the combustion chamber. This particular one has two different pressure controls. One to sense positive, and another one to sense negative pressure, and it's connected to different parts of the combustion chamber. One is here connected to the induced draft blower motor, the blower itself, and the other one is to the secondary heat exchanger collector box, where it is connected to sense the pressure there, to sense their air flow through the combustion chamber. And you see another one located at this portion of it. The other parts of it is the lower portion of this furnace is the blower section. And to run this, the blower has to be on, and there's a switch you cannot see, but it's behind the door to allow the system to operate when the door is closed. If I open the door, it will de-energize the system to keep it from operating for safe conditions. And on this other side of this furnace is the collector box to collect the condensate that will build up inside of the furnace based on the heat it's extracted from the flue gases. As it extracts, it will condensate the flue gases back into a liquid from a gas, and then it would drain to the floor drain. Now, the next thing we're going to do is start up the system and talk about the sequence of operation. As the furnace starts up, the very first thing will become energized is the draft motor, which start the blower, which is doing now, and it go through a pre-purge. The next thing it would do, it would start the ignition system. There is a igniter connected to the system, will start to glow, and it will allow it to heat up, to generate the heat to light the flue gases and the combustion gases for the burners. Once the burner lights, it will prove that there's a flame by the flame sensor. Now the burners are running. And it's continuing to run because the flame sensor is sensing the flame of the burners. It will continue this way as long as there's airflow through the heat exchanger. There's multiple safety controls, such as a high limit control, rollout switch, another rollout switch designed to protect the furnace in case if there's overheat built up inside of the combustion chamber.